Here we're going to discuss the final 4 questions associated with Passage 8 from the Sample AAMC MCAT. If you're interested in our analysis of the associated passage, please check out our previous 2 videos in which we dissect and highlight its most important components. In addition, the first question here was covered in a previous video due to the complexity of this question warranting its own video. You can also check that out on our profile. All said, we're going to start our discussion here with question number 39, which is the second question associated with this passage. The question reads as follows. Methylonate exists in equilibrium with compound X in aqueous solution. What is the structure of compound X? So the first thing we need to do, obviously, is figure out what the structure of methylonate is, and that is given to us in the passage above. So we are going to go ahead and paste it right here just for the sake of easy reference. Now, generally speaking, whenever you encounter a question on the MCAT, you want to try to make as strong a prediction as you possibly can prior to looking at the answer choices to avoid traps set by the test makers in the answer choices. However, in this particular question, there's not a ton given to us in the question stem, so we're going to go ahead and examine the answer choices. So the first thing you may notice about these answer choices is that every single one of them has a ring in it. This implies that methylonate is going to undergo some sort of ring closing reaction. If you think back to what you know about ring closing reactions, you'll realize that this is very similar to when monosaccharides move from their linear forms to their cyclical forms. Here we have the terminal hydroxyl group on methylonate going to attack the relatively electron deficient carbonyl carbon on this carboxylic acid on the opposite end of the molecule. This leads to formation of a 6-member ring in which there are 5 carbons as well as the oxygen from the hydroxyl group which attacked the carbonyl. This enables us to immediately rule out answer choices C and D because neither of these are 6-membered rings. Notice that the carbonyl carbon has gone from being in a trigonal planar conformation to now being an sp3 hybridized tetrahedral intermediate. This tetrahedral intermediate is the key checkpoint for any reaction in which we take one carboxylic acid derivative and swap it out for any other carboxylic acid derivative such as this ester which is contained within our ring. The next step from the tetrahedral intermediate, regardless of what carboxylic acid derivatives we're dealing with, is to reform the carbonyl. This reformation of the carbonyl double bond necessitates loss of a leaving group. So here we're going to have one of these oxygens that is not contained within the ring be our leaving group. Fortunately, the question mentions that we are in an aqueous solution, therefore it's no big deal for a hydroxyl to leave and then be stabilized by picking up a proton to form water once it's out in solution on its own. However, the great thing about the MCAT is that you don't necessarily always need to know everything, because regardless of what happens to this hydroxyl group once it leaves, we can see that reformation of the carbonyl double bond absolutely eliminates any possibility that answer choice B is going to be correct here. So therefore we can go ahead and pick answer choice A with a high degree of confidence and move on to the next question in the series. Our next question also focuses on methylonate and states that methylonate, compound 2, reaction number 3, is expected to display prominent absorption in which regions of its infrared spectrum. And then it goes on to list 3 specific regions of infrared absorption. So what does all this information mean? A lot of people get freaked out to the point of giving up and moving on when they run into spectroscopy and spectrometry questions on the MCAT. Usually this can be traced back to negative experiences with these topics in undergrad OChem courses. However, it's important to keep in mind that the MCAT usually doesn't require the same degree of expertise demanded by some of your more authoritarian professors. In fact, these topics are relatively light in terms of what you're required to know for the MCAT. For instance, anytime you see infrared spectroscopy on the MCAT, what's really being tested is your ability to recognize that absorption spectra correspond to specific functional groups. While it's great for you to have an understanding of the physics underlying these methods, memorizing a short list of absorption spectra and their respective functional groups will enable you to crush the vast majority of IR-related inquiries on the MCAT. We'll explore this topic in greater detail in our comprehensive MCAT prep course, but for now, let's focus on these 3 spectra in particular. The first region listed here is the 3200 to 3500 region, which corresponds to hydroxyl groups. So here we just have to ask ourselves whether our compound of interest has a hydroxyl group, and we see that it has not only 1 but 2 hydroxyl groups present. Therefore, we will have infrared absorption in this specific region of the spectrum. At this point, we know that the correct answer has to have Roman numeral number 1 in it. Therefore, we can go through and mark out all the answer choices that don't have Roman numeral number 1, which allows us to get rid of A and C right off the bat. This is great because it allows us to eliminate some incorrect answer choices, but even more importantly, it tells us that we don't even need to address Roman numeral number 2 anymore because it is in both of our remaining answer choices. And in fact, upon inspection, we can see that Roman numeral number 2 corresponds to the absorption region for the carbonyl functional group, and this molecule definitely does have a carbonyl functional group, therefore we can go ahead and confirm what we initially supposed. Moving on to Roman numeral number 3, we see absorption in the 1580 to 1610 region, which corresponds to both nitrofunctional groups and conjugated rings, neither of which are present in this molecule, thus enabling us to rule out Roman numeral number 3 as being part of the absorption spectrum for methylonate. At this point, we can select answer choice B with confidence and move on to the next question. Question 41 asks us what factor explains how a single stereoisomer is formed in reaction number 2. In order to get a good sense of the context for this question, we really need to investigate reaction number 2 again. So rather than scrolling back and forth continuously, we're going to go ahead and paste it right here below the question. At first, it appears as though you may need a deep understanding of the precise electron pushing mechanism of reaction 2 in order to answer this question. And while a thorough grasp of the mechanism is essential for the question we covered in our previous video, a quick glance at the format of the answer choices here indicates that this question is really more of a pseudo-discrete test of your general understanding of the nature and behavior of chiral molecules. With that said, let's examine our answer choices and determine which are consistent with what we know about producing singular stereoisomers like the product of reaction 2 shown here, rather than racemic mixtures in which we have both R and S configurations around our chiral centers. Answer choice A indicates that our product is optically pure because one of our reactants is chiral. This is incoherent at multiple levels of analysis. First and foremost, neither of our reactants are chiral here. This is honestly enough for you to cross out this answer choice and move on, because if part of an MCAT answer choice is incorrect, then the whole thing is incorrect. Don't fall into the trap of litigating on behalf of an unworthy answer choice. Answer choice B can be eliminated using the same line of thinking. Additionally, even if one of our reactants was chiral, this wouldn't have any effect on the stereochemistry of the product because, as you can see here, the mechanism of the reaction is not one in which stereochemistry would be preserved. To be clear, the chiral center created in our product comes from attack of a nucleophile on an sp2 hybridized carbonyl carbon. These sorts of carbons exist in planes with all of their substituents, meaning that the nucleophile has equal probability of attacking from either side, leading to a necessarily racemic product. This brings us back to the original question. How do we end up with a singular stereoisomer if the mechanism lacks stereospecificity? Well, fortunately, the MCAT is not an essay exam, so let's use the remaining answer choices as our guides for generating the clever response this question demands. Answer choice C suggests that we could end up with a singular stereoisomer if our solvent medium was chiral. First of all, this just isn't a thing. We don't really ever see the chirality of a solvent medium determining the stereospecificity of a product. Secondly, because this is a biochemical mechanism, our solvent is likely to be water, which we all know is not a chiral solvent. So this answer choice is neither clever nor correct, and I feel dumber having addressed it. At this point, you can be supremely confident that answer choice D is correct here without having even read the answer choice itself. That said, the necessary chirality of enzymatically catalyzed chemical reactions is worth mentioning. Enzyme active sites are almost always chiral because they are typically comprised of amino acids, which are chiral molecules themselves. Thus, chirality in the building blocks confers an emergent chirality to the overall enzyme active site. And since the reaction's environment is chiral, the product is going to have a stereospecificity conferred upon it by the mold from which it was made. Therefore, we can go ahead and choose answer choice D not just by process of elimination, but because we know it to be correct from first principles. The final question here turns out to be the simplest of the bunch, so we're going to go ahead and knock it out and then wrap this thing up. The question asks which substance is not a product of squalene metabolism. Outside the context of this passage, most of you would probably find this question impossible due to the simple fact that you have no idea what a squalene is. However, if we scroll back up and take a brief glimpse of the passage, we can determine that squalene is simply a precursor for cholesterol synthesis. Therefore, without so much as a glance at the answer choices, we already know that our correct answer is probably just going to be something that's not made from cholesterol. And upon review of the answer choices, we see that A, glucose, is the only one of these that has nothing to do with cholesterol. Just FYI, testosterone and cortisone, as well as any other small molecule ending in the suffix -one on the MCAT, are going to be steroid hormones, meaning that they are cholesterol derivatives, and cholesterol is, well, itself, so we can go ahead and pick A with a high degree of confidence and move on to the next passage to be covered in another video, which you can find alongside more clear, concise explanations to MCAT passages, questions, and challenging concepts by visiting any of our relevant social media pages or by checking us out on our website at www.onesourcemedicine.com. Thanks so much for watching.